Hello PreCalc. This is our second video, and it'll be viewed Thursday evening or Thursday after class sometime. Should be on the 8th if I got that right. And we're going to continue seeing what's up with radian measure. So, in your comp book, to get credit for this, you need to take notes and show them to me tomorrow. Go ahead and draw a circle and give it a radius that is at this position. And I'm going to give from that radius, I'll call it R, and I'm going to give myself an angle within this circle, and I'm going to call that angle theta. Theta is often used for angle measurement, representing an angle, and then I'm going to see how many radians is this arc that I've intercepted with this angle. So I pick up the radius and lay it on the circle, and it looks like something like 2 point something radians. So I'm not sure what it is, but I'll call the arc length S. So radius, angle, and that angle is measured in radians, not degrees, and this is arc length. So we've seen that already, that a radius is laid along the circumference of the circle, and it then changes its name to radian. And when we are talking about this length right here, it's called arc length, and I'm going to call it S. This is a radius, and that is the angle measure in radians. How many of those radii will fit around the arc from here to here? So I was wondering, and I'm sure you were as well, can you tell me what would be the relationship between S, theta, and R? Would it be something like R times S equals theta? No, that's not it. So in video land, think about what relationship you can come up with between those three variables. Maybe you multiply 2 and get the third, maybe you divide 2 and get the third, add 2 and get the third, subtract. Alright, so think of a relationship between these three variables. Forgot to start the timer, so I've been blabbing, what, about 2 minutes? Alright, so let's see if we have come up with the right one. What you can notice is that this length, S, divided by R, so that is saying how many radii will fit in this S. How many R's are in S? And I already said this looks like about 2 or a little more radians in S. So that would give you the value of the angle in radians. So this is a relationship. And in your comp books, I need you to start a section toward the back that is for formulas. So count about 5 pages from the back and title it Formulas, and S over R equals theta is your first one. So put that in there and indicate that S is arc length, R is radius, and theta is the angle measured in radians. Another relationship that you can put in there is, what does S equal? So if you have S all by itself, you get theta times R. So that's the same thing as this. Put both of those into your comp book. This is just the algebraic rearrangement of this. So I'm getting S by itself by multiplying both sides by R. So this tells me arc length equals the angle times R. Sometimes we'll be asked to use that to do certain problems. So suppose I give you the radius of a circle is 15 inches and the central angle is 180 degrees, and you find the arc length. radius is 15, the angle is 180, and I want to find the arc length. So I'm going to draw a picture of that, and say this is the radius is 15 inches, and the angle, I can draw a 180-degree angle. It is a straight angle, and it starts here and ends here. And I'm going to use this formula to find arc length. So how far is it from here to here, given that the radius is 15? So I'm going to pick this formula. S is what I'm looking for. Arc length is S. Theta is the angle, but I cannot use 180 degrees because this formula only works if you're in radians. So radians only. It only works in radian measure. So you might indicate that in your formula page. So how do I get theta 180 into radians? Well, we did that yesterday. We learned that 3 of those pieces of red wire plus a little bit more equaled 180 degrees. So that turned out to be pi radians. So pi radians is the same as 180 degrees. So in the formula, I'm going to get S equals pi times r. The radius is 15. So arc length is 15 pi, and I'm content, and that's in inches. I'm content to keep it in 15 pi. If you want a better picture of what that is, you can plug in pi into the calculator and times 15, and you'll get something around 47 inches. All right, so that's how you do problems like that, where I give you one of these and you're asked to find the other. I'll give you 1 and 2 of those and you are asked to find the other. All right. All right, the next thing is back in 3rd and 4th grade, maybe 5th grade, we learned that distance is velocity times time, and that comes out to play a lot in physics class and math class as well. So I'm going to rearrange that, and I'm going to write velocity equals, to get velocity by itself, I divide both sides by t, and I get distance over time. These are the same thing, just different arrangements. I'm going to use that, and these facts, the circumference of a circle, the distance around the circle, is 2 pi r, and the area of a circle is pi r squared. So we're talking about a circle here. If that's not something you know by heart, you need to flip back to that formula page and put that in, but you should be familiar with those formulas. So let's look at what's called linear and angular speed. We're going to look at that tonight and see how we can calculate both of those. Linear speed is indicated with a script V, and angular speed is indicated with a script W. So we have V and W to look for. Linear speed, well, we'll do the theory part, and then I'll stop the video, and we'll do part 2, and we'll do an example. And that's all I have for you tonight, is the linear and angular speed we'll end up with. So let's look at linear speed. If something is going around in a circle, around and around and around, it can be, even though it's going in a circle, we can find linear velocity by cutting the chord at any spot at any moment. So in what direction will that object go if I cut the chord right there at that time? So as it goes around and around, I'm going to cut it. Probably from experience, you'll know that this will go straight. So when I'm looking for linear speed, I'm looking for that. If this was to stop right there and no longer go in the circular path, cut the cord as it's spinning, and it would go straight, I can calculate the linear speed at that point. And linear speed is just like this. Velocity equals distance divided by time. Usually, because the distance has been in a circle, we're going to end up using 2 pi r, sorry, did I not say the r? 2 pi r, go back and change that. I thought I said 2 pi r. Anyway, it's going to be 2 pi r for the distance usually, and the time will be given in the problem. And the results are going to be in units like inches per second, or miles per hour, meters per second, some kind of velocity unit like one of those, depending what is given. Angular speed, however, is not calculated like this. It is calculated with the number of radians. Remember, this theta is going to be in radians divided by the time. So we're going to have to calculate the radians and divide it by the time to get the angular speed. Would you add these to your formula section? And I'm going to cut the video now. It's only been 8 minutes. Maybe I'll be able to finish. I'll keep going. Alright. I'll do an example